So I'm gonna elaborate a bit with pointers or on pointers. So there are two extra operators that we can use when dealing with pointers. It's the address operator and the indirection or dereferencing operator. And when I mean operator, I mean things like plus, minus, times, well, even though that's the same thing. But it's just used differently here. These are all operators that we use to do maths and stuff. So this is the address operator, and basically I'm just going to use this as an example. If I say int x gets 7, and then I say there's a pointer to x that I'm going to call x pointer. That's not very good. X pointer. It's not pointing to x yet. I'm just declaring it here. And then I'm saying x pointer gets the address of x. So this is how you assign it to point to that thing. But just note that there's no star there. So that is essentially what the address operator is. And then the dereferencing operator is, let's just see here, I just want to, okay, so you can also say, instead of saying x pointer gets the address of x, let me just explain what's going on here. So I'm saying in this variable is stored the value of the address of x, not the value of x. It's not 7. Wherever this variable x is, which contains 7, it has an address. I'm going to use this. And then this value gets stored in this thing called x pointer there. And this is like indirectly affecting everything. So another way you can say it is using this operator, the indirection or dereferencing operator, saying asterisk is x pointer gets x. Okay, sorry, I just read something. Oh no, okay, that is correct. I'm just going to say something else. So if I want to say something here, x pointer gets 7, you can see this is a bit differently. This is the same thing as saying x gets 7. So yeah, this is equivalent to x, and without the star, it's equivalent to the address of x. So with the star, when you do something with a pointer with the star, I'm going to give this a very weird looking star. Did with the star, it's basically x, and if it's without the star, there's nothing there. It refers to the address of x. So it's just an important distinction. If you were to put them next to each other, they just cancel out, and then it's like nothing are there. Nothing is there. So yeah, that's just the basis. I'm just gonna move over to my code for a practical to explain how you can use this practically in a practical. So I'm just going to show my code here, and there are different ways to refer to things using a pointer. I'll go back to the notes now and explain it again. I just want to show you with an example first. So first, okay, I'm just going to show the output of this. So this is the output. Oh no, that's extremely small. I'm just going to enlarge this. So basically, this output that is produced is just saying the value is stored at a certain index, which I inputted earlier. So I just made an array with values, and then I'm printing out what their values are, and then the address of each memory cell. Yeah, so that is what that is. Just gonna draw that here. So these are the different values. Don't do that. There. These are different values, and these are the addresses of each. Okay, I'm just gonna write down here. These are the different values, and these are the addresses of the different values. And I can access these little memory cells in this array using a pointer with this type of notation, because it's an array. I can use a function, and then I can also use this star notation. So I'm just showing that they'll all give the same output, regardless of which one you use, if you just use it correctly. So I'm just going to go back to the theory, and then I'm going to show how it's executed in this practical. So I'm just going to, just to clarify, the things that I'm doing now is to do with arrays. But just want to say as well, you can do many things with pointers that will be the same thing, which will have the same effect as the certain array element that it is pointing to. So say I'm going to declare a pointer. Okay, now I'm going to declare an array. M as the size of 5. And then I declare a pointer, which is going to point to M. And it gets the address of the first element. Not V, M. Of the first element. I just want to check something here. I think what you also can do, the exact to achieve this as well, you can also write M pointer gets M. This is exactly the same thing. It's just something to remember. So without the asterisks, remember when you initialize it in this line, then you keep the asterisk and you're assigning it to a memory thing. But if you're writing it on the next line, then you don't write the asterisk and just say it gets M. I'm not saying there's a rule with arrays. You don't always have to use the ampersand. But yeah, anyway, this works. This works. You can use that. Or you can say this pointer gets the address of the first element of M. I think that makes more sense. And now you can do things with this pointer. So if I say M pointer plus plus, this increments, this obviously is an increment thing, and what this basically does is it points the pointer to the next element. So if this was M is an array of 5 elements, and I'm just going to write this is index 0, 1, 2, 3, 4. There's 5 elements, but obviously because it starts at 0, the 5th element has an index of 4. And the pointer was pointing to this one. But now I incremented this pointer without this asterisk, because remember, like I previously said, if I was wait, just scratch that. You can check the previous video if you don't, the beginning of the video if you don't understand this. But it's pointing to the first element, as I indicated here, the address of the first element. Now I'm incrementing it with 1, so it's just moving on to the next one. What is actually happening in the background is the value of the pointer, which you know is some weird number, like I just use this number each time, like that, is getting bigger, and so now it gets to 6, 8. But because it moved on, I think 2 bytes or 4 bytes, I think, because it's an integer. You just check 6, yeah. Let's just say it moved on from 60064 to 60068. So it's not important to know exactly what's happening here. It's just some background. That's just the computer pointing to the next memory address, because it automatically sees, okay, it's an integer. An integer on this computer is 4 bytes. So if I incremented it to go to the next element, it is going on to the... if I go on to the next element, it's actually moving on to the next address. But it's not important. All you have to know is that when I do this, it just goes on to the next element. And you can then say M pointer plus 2 plus equals 2. That's just saying m pointer gets m pointer, no, this would p, plus 2. Then it just goes on to that one. Yeah, so you can do funky stuff with that. So there are 3 types of ways to, or many types, but I'm just going to discuss 3 quickly here. How to handle these, or how to access these elements. So if I want to access the element v3, there's some array named v, and there's a pointer called v pointer. Just going to say this, v pointer equals v. You can say that. It just initializes it to the first element in the array, I think. And this v is how big? Let's just say it's 5 elements big. And I want to access element v3. You can do it using offset notation or pointer notation, but it says offset notation, and that's just going asterisk and then in brackets the pointer name, which we called v pointer, plus 3. So that just goes to the one that it's pointing to. Is pointing to the first array element, and then goes 3 on to go to access that element. Then there is subscript notation, and that's where you just say v pointer 3. That is exactly the same as saying v3, because it's not, there's no asterisk, just, yeah, that is the same as that. And then you can do pointer arithmetic on an array. So if you say v plus 3 and they put it in brackets and put a pointer there, it points to the array. Okay, so I just want to say v is an array. So it's an array is an address that contains a certain element that contains a value. So I'm saying v plus 3, so it's moving on from the first element to the third one, and I want to know what the value is, so I just put that there. So that is arithmetic, pointer arithmetic. Yeah, arithmetic. So I'm just going to go back to the computer example, or how it's practically implemented. Okay, so this is my code, like I previously said. So what I first did is, just let me draw on this. I zoom in perhaps. Yeah, anyway. So I first initialized an array of size 5, and then I assigned values to each of the 5 elements. And then I declared a pointer as well that I'm going to use later. I just also put in I for a counter. So first I'm going to refer to these values just a normal way. So I'm using a loop because I want to display each element. So I'm just going to show you again here. You can see that I am showing the value stored at index 1, at index 2, at index 3, and index 4. So it's basically looping through each element to show what is stored there. And that's why I'm saying for each element, yeah, this is a for loop. You can look at the for loop video that I made if you don't understand for loops. I'm not going to explain here. So I want to print the value stored at index number, because I'm in a loop and I'm saying the first one's 0. I'm just going to put in there I, which is going to be 0. I'm referring for the first element now, and then it's going to print the value. The value is array. Oh, okay, my name of the array is ARR. So ARR I, which would in this case in the first one be 0, and then I'm going to say the address at index whatever, which is again I, is the address of that thing. So that's simple. You know the ampersand is the address of something. So the next one, whether we're going to access this variable, these elements of this array, is referring to the memory block by using pointer with, what's this called? I think subscript notation. Yeah, subscript notation. So using these stuff. And yeah, I'm saying value stored at index number, and for the first one it's going to be 0. Obviously it's going to increment each time, go to 1, 2, 3. But I'm just going to say for the first one, so it's at element 0, it's going to be a value, and the value is pointer and then I. You can see here it's array I, or ARRI, and here's pointer I. Like I said before, if you use pointer or ARR without the star when you're dealing with arrays, it is exactly the same thing. It's going to print what value is stored at element I. So then I just print I again, because I say address at index so and so, which is in the first case going to be 0, is, and then I use percentage %u. This is what you use if you're printing the address. There's a different one that you use for hexadecimal form. I knew it 5 seconds ago, I don't know anymore, but I'll just, when I find it out, I'm going to put it in the description of this video. Then you say the address of pointer so and so and so, because I said this is exactly the same as that. It's just, yeah, that's just how it works. And then we're going to refer to it using the asterisk notation or offset notation. So again, I'm saying the value stored at index so and so is, and then I print the value that's stored there. And what I do is I say pointer plus the offset from the first. Okay, sorry, I know I'm interrupting myself, but I just want to specify here. I set the first element of the array to be the thing that the pointer points to. There's no asterisks here. I just say the pointer is the array. That's why it can be used the same thing each time. You can see here. You can also write star pointer is equal to array 0. This is saying that I am pointing to the first element of this array. But you can just say this. It works exactly the same. So here I'm saying pointer plus the offset. So in the first case, the offset or the I is 0. So it's going to be the first element, and with the asterisk in front of it, it's going to print the value of that first element, not the address, because this is the address. That's the value of the address. That's what we want to print. And then the address at index is the same, I. And then you can say here, the address plus the offset from that first address is going to be printed at the end, because because like I said, this is the address, and we want the first element in this case, which is element number 0. If I was looping this and I came to I equals 2, which is the third element, and I want to access element of index 2, it's going to say pointer plus I, which is, and where I is 2, and it's going to be the address of the first element with an offset of 2. So if you're referring to the address of something using a pointer, no asterisks or anything, just say normal thing with the offset. If you want the value stored there, just include the asterisks. So afterwards, I used a function to do the same thing. So my function is called pass pointer, and then the argument is the pointer that I declared here. The function itself is up here. Here, void pass pointer, because I'm not going to return anything. I just want it to do something. If you just want the computer to do something without returning a value, you just say void. And then it's double, which is the argument. It's going to be a double, so extra long floating point number. And then it's going to take on a pointer as an argument. Here you can see I didn't put a star in here because I'm already said here I'm going to be using a certain type of pointer. So now here I just put in the pointer name. You don't have to put a star in there as well. And here's my function definition. So obviously just start by writing the function, and then curly brace, and everything inside here is the function. So I'm looping through each element again for the 1D array. And what I'm saying is the value stored at index so and so, which is going to be I again, is the pointer. So I'm saying that it's using the pointer like this. It's basically saying star pointer if you're just using it up in here in main. But you just see, if you say star and then the pointer name, that'll give you the value that the pointer is pointing to. That's what we want. And then comma I again. And then because the pointer is just an address, I can write without the star. So pointer on its own is the address. And then I incremented each time. I looped because I wanted to refer to the next element in the array. And that is basically it for pointers and arrays. Yeah.